Grenton Academy, Part 5. The basics of the Smart Home System configuration. Hello, my name is Mark Pollitt and I invite you to the next part of our training, where you will learn how to start creating configuration in the Grenton system. Before we start creating our first configuration in the system, I would like to present in 2 words what tool we will use. Object Manager. Object Manager is a configuration software with which you're able to configure all functions of the Grenton system. You don't need one program to address modules, another to create an interface for mobile devices, and another one to create logic. You can configure all the functions of the Grenton system with one tool, the Object Manager. This tool has one very nice function, the Object Discovery function, which allows us to add all modules connected to the system to the project in a very simple and quick way. We don't have to connect to the modules, we don't have to address them, we do not need to know the IP address of the module that will be connected to our system. All we have to do to physically connect all modules with each other, activate one function, and all of them will automatically be in the Grenton system. Exchanging modules works just the same. If we want to exchange a module for another one of the same type, we simply connect them between themselves. Run the discovery function, one click, and such a module is already replaced in the system. Ready, configured, and can start working. Everything works on a plug and play basis. Interfaces for mobile devices is the next thing. In earlier films, we discussed the fact that each user, basically every member of the household who uses the Grenton system, can have their own control interface that will be tailored to their preferences. And in the Object Manager, you will find tools for creating this type of interface. And finally, a number of virtual objects that we have prepared to speed up the work on creating configurations. Script Builder. Script Builder is a tool that we have prepared to create complex logical algorithms. We can create scenarios here, the simple ones, but also advanced complex control algorithms using blocks, i.e. in a very simple visual way, we drag a component to the working area, we connect them together, and they will work exactly in the way we connect them. A very simple, very intuitive tool that allows us to create our own concepts, our own control algorithms. Additionally, we have the option of performing arithmetic and logic operations here, i.e. these algorithms can be really complex. We also have the option of using variables, both local and global ones. If creating scripts in a graphic way was not enough for someone, it's possible to write them in scripting language, in LUA language, and here all the possibilities of creating configurations, creating programming can be used. Loops, variables, arrays can be used, and in that way create really complex scripts, scenarios, or integration interfaces to other elements, to other systems. As I mentioned earlier, we also have a number of virtual objects available. There are ready-made logic blocks able to perform certain functions, and we do not need to script them. And the first such block, or the first such virtual object, is the timer object. i.e. we have a timer in the system. For each CLU module, it is possible to create up to 64 such timers, and the timer can work in 2 modes. Counting, i.e. countdown mode. After counting down the time, it can also perform some other action, for example, open the door, turn on the lighting, or start a scene. But it can also work in interval mode, i.e. in a cyclic mode. That is, after specifying time, it can perform a certain action and start counting again from the very beginning. We have full control over the timer. It can be stopped. Its assigned values and parameters can be changed during its operation, as well as its settings. Another virtual object that we have at our disposal is the calendar object. It is based on the Chronovsky rule. Here, on the slide you can see how the rule looks like. In the calendar configuration, in the Rule tab, there is the option of setting the date, time, maybe not necessarily the date as such, but a specific day of the week, month, hour or minute when something is to happen. i.e., the calendar is a great tool here to create automatic scenes for a wake-up call, for opening and closing roller blinds, or for reminding about certain situations that are to take place at home. There is also a schedule object available. The schedule object allows you to set your own values, but in a 7-day resolution, i.e., as in the case of the calendar, we have the whole year available. Run devices with the specification of what month, on what day of the month, at what time, at what minute. In the case of a schedule, we can run objects or set them within weekly values, i.e. within 1 week. Different values can be set for each week, at a different time, at a different hour, with an accuracy of 15 minutes of each hour. Thermostat is another virtual object that helps us create configurations. The virtual thermostat works based on a hysteresis controller and allows to control the temperature in 64 zones for one CLU module. i.e., if we want to control the home heating in zones, there is no need to install thermostats in every room. i.e., there is no physically hanging on walls, to put it simply. These zones can be controlled using these virtual thermostats, as well as managed from a smart panel or application level. In order to the fact that the thermostat uses a hysteresis controller to control the temperature in a given room based on the set of parameters, there is a number of interesting functions, such as heat up or holiday mode, and ability to switch from cooling to heating mode, which would definitely be useful when creating one's own algorithms for heating. Since you know more or less what functions you can expect in the Object Manager, let's go to the configuration. Before we start creating the logic, it's worth getting to know how the Grenton system works. Grenton is a system that works based on event-generated model. This means that every action that happens in the system generates certain events, to which can be then assigned certain actions. To put it graphically, if there is a lighting key connected to the outputs in the digital in module, and someone presses such a key, then exactly at the moment the key is pressed, an event appears in the system. It might be, for example, on click or switch on. An event will simply appear. And now, as part of creating the configuration to such an event, we will assign what is to happen. So, we will assign what method to use to start the control, exactly as we have in this diagram. If I press the button, the on-click event appears, and then the system says that it assigns the switch on method to the on-click event, i.e. turn on the output. That is exactly how the whole system will work, i.e. the whole action. Whether it will be the appearance of a specific state on the output in the digital in module, or whether it will be pressing the button on the touch panel, or whether it will change the temperature value or generate a certain event in the system. And now, during the configuration, you will decide what to do if such an event is generated. This means that when I press the button, then do this and do that, it is exactly how the system logic works. In this way, we create and build the entire configuration. Let's then work with the project. First of all, a handful of basic information. To be able to configure the Grenton system, we must connect to the CLU module. The connection can be made directly, i.e. we need the computer touchpad UTP cable to connect to the LAN socket on the laptop or computer, and then connect to the socket that is on the CLU module. In CLU, we have a 2-port switch, so it doesn't matter if you connect to the left or right socket. It is important that this connection is made. we can connect directly from the computer to the CLU module, and this connection will be correct, and it will be possible to configure the system, but it can also be done using a Wi-Fi router. To put it simply, this will probably be the most convenient option if you already have all the modules connected in the switch box. A small digression. Before you start creating the configuration, it is worth preparing the documentation for this system. So the order of work should be more or less like this. Connect the modules in the cabinet, all control modules. Connect the I/O modules to them. In this case, we make project documentation, i.e. we write that for the entrance in module 1, the first input, the switch in the living room, was connected to the entrance 2 sensor from the corridor, to the entrance 3 switch from the kitchen. Of course, the serial number of this module should be noted as well. We proceed in exactly the same way with all modules, and at the moment when the system is described, it should be connected, powered on. The CLU module should be connected to the Wi-Fi router on facility. Then we can sit comfortably in front of such a system. There need not be a cable connection, and start creating the configuration. Of course, before starting work, make sure that the system is powered up, i.e. that the LEDs on the CLU are flashing correctly. Before the first startup, you will see in the red and green LEDs will blink alternately, and this is the correct reaction of the system. I.e., if you unbox the new CLU module, connect the power supply, then red and green LEDs should blink alternately. We make sure that the system is properly powered, make sure that the LAN cable is connected to the CLU, and for example that it is connected to the router, and at this moment we download the link from www.grenton.pl that you can see here, i.e. from the tab on the support page. You will find there downloadable materials and the latest version of Object Manager. That is, download the latest version of Object Manager on the computer, unpack it and install it, and start creating a new project. After opening the Object Manager, you will see a window with a Project Manager here. So the first thing we do is click on New Project. Then give the name for this project. And here is the first tip. When using the names for the project, it's worth sticking to some kind of transparent scheme. Ideally, it may be the location of the object, street, house number, and for example date or last version. Try to avoid naming projects as last version, good version, final, etc. Because if we work on this project for more than one day, it may turn out that there will be a lot of these versions, and at some point you may get confused. Which is why it's very important to adopt a certain pattern that was transparent to all people who will come into contact with the project. For example, as I said before, it can be street name, customer name, and possibly a date. For example, saving the final version is a good practice at the end of the day. So we finish the work with the project, finish the day, save the configuration, and then we know that the project is finally working at a given moment, and it's always the final version of the project. Okay, so enter the name for the project. Here below you can see the location where this project is saved. At the end we see the name of the project with the extension OMP, and this is exactly the project file, which can be copied from this location, saved to the cloud, and simply stored in a place more secure than the disk of the computer. We go to the next step, in which we will set the address range for the CLU module. As you already know from previous videos, CLU is a network device, i.e. it must have its individual IP address. And in this window, the range in which the CLU will receive an IP address during the CLU discovery process can be precisely set. Here is another important piece of information. The CLU module does not support DHCP, so the address it receives will always be a static address. So in the case of our range, it's worth setting up the address range from the field outside the DHCP pool of our router. If your router supports DHCP in the 1 to 100 range, then set the beginning of the range, for example from 101, and then be sure that no other device in the network will receive the same address that was given to the CLU modules. And here, one more piece of information. As you can see, the IP address that my Object Manager displays is from the pool 169.254.190. I do not have such an address set static. This address is due to the fact that I am connected directly to the computer with a cable, bypassing the router, and my Windows has automatic addressing set in the network parameters. In the case of automatic addressing, the devices just get an IP address from such a strange range, so there's nothing unusual, nothing incorrect. If you have an automatic IP address setting for the LAN card, then exactly your CLU will get the address in this range. When connecting CLU through a router, the address received by your CLU will be compatible with the pool of router addresses. In fact, with the network your computer will be connected to. Fine, we have now set the range of IP addresses, then we move to the next step. And in the next step, and this is a very useful function, when creating new projects, i.e. what we are going to do today, select option 2, clear the configuration on all CLUs found. This will cause that when we find CLU, then its memory will be cleared and we start working with a new project. If for some reason we lose the project in the system that we configure, the computer crashed or any other random situation happened, or we are passing an object that was configured by someone else, at this moment there is the option to download the existing configuration from that system. Then select the first option and we will download everything except for two things. That is, we are able to recover the entire configuration. We will not recover the interface for mobile devices. They are always an integral part of the project file. The interfaces will have to be recreated, and all scripts that we download from the system will not have a graphic form. But they will have a textual form, but the syntax is quite simple and clear. So I think that there should be no problem deciphering what the scripts are about, how the scripts work. Okay, so in the case of our system, select Clear Configuration from all found CLUs. And now, at this step, after starting the CLU discovery function, the system starts searching the network to which our computer is connected in order to search for the CLU modules that are also connected to the same network. And now, in our case, we can see that CLU has already been found. If I had more than one CLU connected to our system, there would be information how many of these systems were found. But there may be some situations that, despite the fact that the CLU discovery function was activated, no CLU can be found. What should we do in such a case? First of all, we start the diagnosis from the simplest of issues, i.e. first we check whether the CLU module is well powered. We already know how to do it. In the second step, we check whether the CLU module is definitely connected to the LAN network in which we run the configuration. And another two issues. If, despite the fact that the first two steps are okay and we still cannot find the CLU, it's worth disabling the firewall and for the time of configuration and check it. It can be important, especially in the case of older computers with older versions of Windows. Although a lot depends on the device you work with and on the manufacturers of the software that is in it. These can sometimes be other firewalls. It will not necessarily be the Windows firewall. it could be a firewall of some other antivirus system that treats the CLU discovery function as a malicious attack and blocks it. And the last thing to check in this case is whether any virtual network cards have been created in the computer. Sometimes a VPN connection is made up with this type of cards, sometimes with some programs. Virtual machines also clone real cards and create virtual cards. So it's worth checking those 4 points before completing the discovery process. Or whether there are problems with finding the CLU. If, despite meeting all these points, you still have a problem finding CLU, then in such a situation it will be best to perform a hard reset. i.e., turn off the power, press the link button, turn on the power for about 10 seconds. After 10 seconds, a confirmation of the procedure hard reset will be seen, i.e. the green and red LEDs will flash quickly at the same time, and then try again to perform the CLU discovery function. And in this case, the CLU modules should definitely be found. Let's turn to the Object Manager now. As you can see, at this point, the Object Manager asked me to provide the encryption key. You cannot add a CLU module to the project for which you do not know the encryption. So there is no possibility that a neighbor from the next block will connect to the network, launch the CLU discovery function, and take control of the system. No. To be able to add, create configuration and configuration changes, you must have a current project key. Where do you get it from? Now you can see the encryption key is located on the CLU module below the serial number. In my case, it has a form consisting of numbers and letters. It is OD2C34FD. And exactly in this way, we have to enter it into our Object Manager, case sensitive. Let's check if it is so. OD2C34FD. Okay. And in this case, click OK, and after correctly entered encryption key, I can add CLU to the project. And now let's stop for a moment at the window we see. Here is the name of our CLU module, which consists of the prefix or CLU and the serial number of this module. See what IP address has been assigned to it. This is in line with our set range, i.e. 245. We've set from the 101 to 255. We can change the IP address that was set. We add it to the project, but there is another inactive window here. In a situation where, like now, a new project is created and the configuration is cleared, and CLU is being added to the project, simply click Add All CLU. If there are more of them, and it is possible to continue working. However, in a situation where our CLU module would be damaged for some reason and it needs to be replaced with another one, in the case of the Grenton system, the entire configuration is stored in the project, i.e. in the project file that is now being worked on, and in the CLU module. So if the CLU is replaced with another one, it simply won't work. Therefore, the whole configuration has to be done again. And here we have prepared a special tool so that you do not have to create this configuration from the very beginning from scratch. If you have a project saved file, then all you need to do is to open the project file for such an object, run the CLU discovery function, open a new CLU, then in this window, the assign to inactive function will be active. When you press this button, you will see a list of inactive CLUs from our project. You will be able to choose the CLU that will be replaced, select them, and at the moment of rewriting it, the entire configuration from this old CLU module will be rewritten to the new one, and you will not have to do anything more. With 2 clicks, you'll be able to restore the full functionality of the system. Okay, but we keep going on with our project, which means we add all CLU modules to the project. At this moment, the configuration of the CLU is cleared, the configuration is reloaded, and you should immediately see the CLU module and all objects from the inputs, from the outputs, i.e. from all modules that are connected to it on the tree. And now, as you see on the CLU module, you will see that the red LED no longer blinks. Only the green LED blinks with a frequency of 500 ml. This is the correct state of the CLU. This state that was seen earlier, i.e. alternately flashing red and green diode, means the so-called emergency mode, which is typical for the new CLU as it has no configuration yet. If the system has already been configured, it has been programmed. The only valid state is the green LED, which blinks at a frequency of 500 ms, which is exactly how we see it on our CLU module. I will show one more status for the CLU module. This is another issue that is worth being aware of from the very beginning of working with the system. Namely, if as now we disconnect one module, i.e. if the CLU loses communication with any of the modules that are connected to the bus, then you will see that the red LED on this CLU module lights up almost immediately. If you come to an object where this state will remain, i.e. you will see that the green LED is blinking and the red one is lit continuously, it means that either the bus was interrupted somewhere and the CLU is not communicating with any of the modules, or one of the modules has been disconnected. In other words, the configuration does not work properly. This state allows the systems to work in the part that is connected to the CLU, but it can manifest itself in some kind of delay or instability. So you should always bring that to the state. Oh, you see, after connecting the modules, the red diode goes out immediately and the system returns to normal, stable operation. Thank you very much for your attention, and I invite you to watch the next films. See you.